Hello everyone. So in this video we will study about the basics of differential equation. Okay. So we'll start from very basics and whatever we need to know for network analysis that we will learn. Okay. Not the complete basic differential equation but whatever we need to know for network analysis that we will learn. Okay. So what is the order of differential equation? You must have studied it in 12th class. What is the order? So highest order derivative. So in this equation, what is the highest time the derivation has been done? What is the highest time the derivation has been done? First, right? Once. Here 0 time differentiation, here 1 time differentiation. So this is first order. Okay. Tell me in the second equation, what is the highest time the derivation is done? Here 4 times? No, 1 time only, right? But here 3 times. Here once and here thrice, right? Here once. Okay. So this is third order, not fourth order. This is just a power. Okay. This is the number of differentiation. So this is third order. Okay. So that's how you need to know what is the order of the equation. Okay. Now some important point are there is that whenever you find d by dx, replace it with the d. Okay. D by dx will be replaced with d and integration will be replaced with 1 by d. Now don't ask the region and anything. Even I don't know. Okay. So just go with the flow. That's how we need to solve it. That's it. We are not mathematician or anything. So whatever we need to learn for network analysis, that we will learn. Even in the maths, they won't explain you the region for writing d by dx equals to d. Okay. So yeah. So let's assume this is a given differential equation to us. Okay. This is the given differential equation. A naught d square y by dx square plus b naught dy by dx plus c naught y equals to qx. It is a some function of x, some function of x. Okay. So how we will solve it? A naught d square plus b naught d plus c naught. Are you understanding this point? If you are not understanding, I will write it like this. A naught d by dx is replaced with d. So d square by dx square will be replaced with d square and y will be remaining as it is, plus b naught d by dx will be replaced with d, y will be remaining as it is, plus c naught y equals to q of x. Now can you take y as common? Y common outside. So a naught d square plus b naught d plus c naught y outside equals to q of x. Now what is this? This is a function of d, right? It is a function of d. So I can write it like this. Function of d y equals to q of x. So any differential equation can be broken into this. A function of d into y equals to some function of x or a constant. Some function of x or constant. It can be a constant too. Okay. Some function of. So any differential can be broken into this part. Function of d into y equals to some constant, some function of x or constant. Okay. So that's how it can be broken. So now this is our equation. Now based on the value of qx, there can be two solution of y. This is our equation, right? Fd into y is equals to q of x. Now based on this, now based on the value of qx, there can be two solutions. If qx is 0, if qx is not 0. So if qx is 0, you will have only one solution, that is like only one thing you need to find, that we call complementary function. CF, complementary function. The spelling can be wrong. Okay, complementary function. And if qx is not equals to 0, you will need to find two things. CF, that you have already found here, and one more thing that we call particular integral. Particular integral. Okay. So if qx is 0, only one thing you need to find, complementary function, and that will be equals to y. If qx is not equals to 0, you need to find two things, complementary function plus particular integral. Complementary function you have already found, and then you will add the particular integral. Now how to find CF and PI? So first we will see how to find CF. Okay. So this is our equation, right? FD. So this FD we will take out a naught d square plus b naught d plus c naught. This FD we will take and put it equals to 0. So put FD equals to 0 and find the roots of the equation. Okay, we have this equation. FD is equals to A naught D square plus B naught D plus C naught. We will put that equals to 0 and find the root of D, find the root of this equation. So based on the equation, let's assume if it is third order equation, how many roots it will have? 3. Fourth order, 4. Second order, 2. First order, 1 only. So based on the roots, that's how we can define the based on the roots we can define the CF. Let's assume we are having two different roots, alpha and beta. So what will be your CF? CF will be C1 e to the power alpha x plus C2 e to the power beta x. Okay, you need to remember it. There is no other option. You need to remember it. Okay, alpha beta, C1 is constant, C2 is constant. Okay, C1 and C2 are some constant that we don't know. Okay, now if there are two same roots, then what will be CF? C1 plus C2x e to the power alpha x. Now if there are three different, C1 plus C2x plus C3x square, sorry, x square e to the power alpha x. If there were four, C1 plus C2x plus C3x square plus C4x cube e to the power alpha x. Okay, so that's how you can keep on increasing the power. Okay, now there are two same, three same and one different. So how will you write? For two same, what will you write? C1 plus C2x e to the power alpha x. For three same, what will you write? C3 plus C3x plus C3x square e to the power beta y. C3, oh, okay, sorry. C3, C4, C5. Different variables needs to be there, no? So C3, C4 and C5. C3, C4 and C5 plus C6 e to the power gamma y. Are you getting this point? Okay, 2 same then C2 into x, 3 same then C4 into x plus C5 x square, and none same, only once it is there, so simply the constant into e to the power gamma y. Similarly here. Now fifth one, so it would be e to the power alpha x. Okay, you need to remember it. So now we have the roots as alpha plus iota beta and alpha minus iota beta. So there are two roots, alpha plus iota beta and alpha minus iota beta. So what will you do? You will put the real part and e to the power real part into x. And then what will you do with the imaginary part? You will write it like this: C1 cos beta x plus C2 sin beta x. Are you understanding this point? Are you getting this point? In this, what will you do? You will take the imaginary part first, sorry, real part first, C1 e to the power alpha 1x. Then put the imaginary part in sine and cos, right? Then there is one more root, so plus e to the power alpha 2x C2. Here C1, C2 is already there, so I will write C3 cos beta 2x plus C4 sin beta 2x. Okay, just see the table, take your time to observe it. Okay, just observe it once. What we are doing? Alpha, beta, two different roots, C1 e to the power alpha x plus C2 e to the power beta x. Same roots, C1 plus C2 e to the power alpha x. Three different roots, C1 plus C2x plus C3x square e to the power alpha x. Two same, C1 plus C2x e to the power alpha. Three same, C3 plus C4 plus C5 x square e to the power beta y, and one only, so C3 e to C6 e to the power gamma y. Just make sure you use different variable for everyone. Okay, just don't use the same variable again. Here as well we are using two different variables, C1, C2, and e to the power alpha x is outside, e to the power alpha 1x is outside, and imaginary part goes into sine and cos. Same here. Okay, so this is the way you write CF. Okay, so that's you need to remember. Especially this is the most important one. Okay, and this is also important. Okay, these two are the most important one. Sometimes this is also important. Okay, so these you need to remember for sure. Okay, so this is how you find CA. Now let's just come to our question. So what do you see? First thing you see here is that here Qx is equals to 0. So y will be equals to CF. So now what is your f of d? F of d is d square plus 12d plus 36. Are you understanding this? How did I write the f of d? D square y plus 12 dy plus 36y. So I just took y equals to common, y common, and this is over f of d. Now we will put f of d equals to 0. So d square plus 12d plus 36 equals to 0. So from here you will get two values of d, that will be minus 6 and minus 6, same. Okay, same values you get. So what is your CF now is equals to y, that will be same alpha and alpha. What is that? D equals to alpha and alpha. So what will you write? C1 plus C2x e to the power minus 6x. That's it. Why did I write x here? Because this was dy by dx. If it was dy by dt, what would I write? T. With respect to what? Differentiation with respect to what? With respect to t. So I would have written t here. If the differentiation is with respect to x, I am writing x here. I hope you know this point already. So if you don't know, I have already explained that if t is there, I would write t here. Okay. Let's move on to the next question. Here, this is the equation given. Also, some conditions are given too. Why these conditions are given? To find the values of constant. So first, what we will do? Q of x is 0. That means y is equals to only CF. Here, your f of d is what? D square plus 36d. So what we will do? Put d square plus 36d equals to 0. So what we will get? D value as plus minus j6 or iota 6. Are you getting this point? D square equals to minus 36 and d value will be plus minus j6. Okay. So what is this form? This form is alpha plus minus iota beta. Here alpha is equals to 0. So what will be your y is equals to complementary function, that will be e to the power 0x c1 cos beta x plus c2 sin beta. Beta value is 6. So I should write c1 cos 6x plus c2 sin 6x. Okay. So this is our final equation. Y is equals to c1 cos 6x plus c2 sin 6x. Okay. Now this is the equation, but this is not the final answer, right? Why it is not final? Because there are some given conditions. What is given? Given at x equals to 0, at x equals to 0, y equals to 0. That means y is equals to 0 at x equals to 0. If I put x equals to 0 here, cos 0 will be 1. Plus, if I put x equals to 0, sin 0 will be 0. So that shows your c1 is equals to 0. Now your y is reduced to c2 sin 6x. Okay, this is reduced to this part. Now what is also given? Given at x equals to pi by 12, y is equals to 1. That means at x equals to pi by 12, if I put x equals to pi by 12, if I put x equals to pi by 12 here, so it would be 6 pi by 12. That will give you pi by 2. And what is sin pi by 2? Sin pi by 2 is 1, right? So this value reduced to 1. So that means y, that is 1, y is equals to 1, that is given. And this sin 6x is also reduced to 1 only. So your c2 is equals to 1. So here c1 is equals to 0 and c2 equals to 1. So what is your final answer? The final answer is y is equals to sin 6x. Okay. So by the given conditions, what did you do? You found the value of c1 and c2. c1 came out to be 0 and C2 came out to be 1. That was simple mathematics that you solved. Okay, easy, well and good. Okay, let's move on to the next concept, that is how to find particular integral now. Okay, we have found CF, now how to find particular integral. When did you need to find particular integral? When Qx is not equals to 0. Okay, so what is the given equation? Fd into y equals to Qx. You will put y equals to Qx into Qx by Fd. Fd into y equals to Qx is given. You will put y equals to Qx by Fd. Okay, now this Qx can be anything. It can be exponential, right? Or it can be sinusoid. Okay, it can be sinusoid, right? Or it can be a constant, right? Or it can be any what do we say? We can't say equation, like in any power, like it can be like x square plus x plus 2. Okay, it can be like anything. Okay, so it can be anything, but for network analysis we will only learn for the case Qx equals to constant. That's it. Okay, we will only learn Qx equals to constant. Let's assume your Qx is C. Okay, so we will only learn for that case. If Qx equals to C, just write C upon f of 0. That's it. That's your particular integral. Okay, so I will take an example. We will understand that. So what is your particular integral? We will only learn for the case of Qx equals to constant. In network analysis, we will always have this Qx equals to a constant value. We will not see for the sinusoid case or cosinusoid case. If we ever get to see sinusoid or cosinusoid, I will tell you the solution there only. Okay, but mainly for now we will only see for constant case. Okay, so 18 is the constant, just like that. So we will put 18 upon f of 0. That's it. That's our answer. Okay, so let's solve this example. So here q of x is 18, that is not equals to 0, and which is a constant, right? So this is not equals to 0. So now your y will be CF plus PI. So first we will need to find CF. So what will be CF? D square plus 12D plus 36 equals to 0. So what we will get? We have already solved it, right? Minus 6 and minus 6. So your CF would be C1 plus C2x e to the power minus 6x, right? So this is what we will get. Now how to find Pi? So now we will find Pi. For Pi, what we need to do? D square plus 12D plus 36 into y equals to 18. So y equals to 18 by d square plus 12d plus 36. Now your particular integral would be, when for your particular integral, what will you do? You will put d equals to 0, right? For particular integral, you will put d equals to 0. So it will be 1 by 2. Putting d equals to 0. Just like here I have explained, right? I have explained, put d equals to 0. Put d equals to 0 in f of d. So this is our f of d. You just put d equals to 0. So your answer is 18 by 36 equals to 1 by 2. So I guess I can reduce this line. So now what is your y? Y is equals to CF plus Pi. What is your CF? CF is C1 plus C2x e to the power minus 6x plus Pi is 1 by 2. This is our final answer. Okay, so that's how we need to solve. Okay, no need to put much stress about differential equations. Just the very simple thing that I have told you. That's all that we will be using. What I have told, how to find CF, how to find. Just assume we have got these two roots, minus 6, C1 plus C2x e to the power minus 6. If we have got these kind of different roots, then it would be C1 plus e to the power alpha x plus E2 plus e to the power beta x. Okay, sinusoid and cosinusoid we can get like this. Then I told you to find pi for only one particular case when qx is constant. So if it is constant, put d equals to 0. That's it. C upon f of 0. That will be the equation. Just like this. C upon f of 0, 18 by 30, 1 by 2. Just add them up and that's it. That's your answer. Okay. And let's just assume if this 18 was 0 only. So what will be your pi? Pi would be 0 upon some function. So it would be 0 only. So that's why we don't consider pi in the first case when qx equals to 0. But when qx equals to constant, we need to consider the pi. Okay. So that's it about the differential equation. So in the next lecture, this is a very okay. Before going to the next lecture, we will solve a general first order equation. Okay. Yeah, right. This is a very important point. We will solve this general first order equation. So this is the given equation to you. So how will you solve it? AD plus B y is equals to C. So your y will be CF plus PI, right? So first I need to find CF. So how will you find CF? So for CF, AD plus B is equals to 0. So your D will be equals to minus B by A. So your CF is what? Only one is there. So I will write. So for one, I didn't tell you actually. Like similarly, here I told you for two roots, right? Alpha. If this alpha is not there, let's just assume if beta is not there, then we can put beta equals to 0. Sorry, if beta is not there, just don't consider it. Okay, only alpha will be there. So C1 e to the power alpha x. That's it. Okay. So only one root is there. That is this minus b by a. So I will put C1 e to the power minus b by a into x. So this is my CF, right? Oh, t. Now we are doing with respect to t. Okay. So here I will put t. Okay. Are you getting this point? Well and good. Just solve the equation and C1 e to the power minus alpha t. Okay. So this is the value of the equation is C1 e to the power alpha t. So value of alpha is minus b by a. Okay. So yeah, this is your CF. Now how to find pi? For pi, what will you do? Pi y is equals to C upon AD plus B. Put D equals to 0. So your pi would be equals to C by B. So pi will be equals to C by B. Now what can I do? What will be my y? Y will be equals to C1 e to the power minus C1 e to the power minus B by A into T plus C by B. Right? Plus C by B. This is a function of t, so I can write yt equals to this. Like this is a function of t, right? So yt equals to. Now see one thing, at t equals to infinity, what will happen? Y of infinity, like this is our final equation of yt, that also I need to put in the box. Now if I am putting t equals to infinity, so what will happen? Y of infinity will be equals to, this value will go down to 0. I have already told you e to the power minus infinity is 0, e to the power infinity is infinite, e to the power 0 is 1, right? So if I am putting infinity here, e to the power minus infinity will go down to 0, so this will be 0. So y of infinity is c by b. That's a constant value, right? So y of infinity is c by b. So I can reduce my yt equals to c1 e to the power minus b by a t plus y of infinity, right? Now what do I do? At t equals to 0, what will happen? Y of 0 will be equals to c1. At t equals to 0, this will go to 1 plus c by b, that is y equals to infinity. Sorry, y infinity. Look, I will put t equals to 0 in this equation. This will go to 1. C1 plus y infinity. I am putting t equals to 0. So what will be your C1? C1 will be y naught minus y of infinity, right? I can put these two in the box as well. You have found the value of C1 and also y of infinity. Sorry, y of infinity is C by B and your C1 is y of 0 minus y of infinity. So how you can write yt? Your yt can be written as y of 0 minus y of infinity e to the power minus b by a into t plus y of infinity. So, or how you can write y of t is equals to constant value first, y of infinity plus y of 0 minus y of infinity e to the power minus t upon tau. Okay. So this is what you can write. This is general solution of first order differential equation. Are you getting this point? And here tau is a by b, right? Tau is a by b. Okay, so you don't need to remember what is tau. For finding tau, I will tell you the method. Okay, don't put much stress on this tau for now. For finding the tau, I will tell you one method. That is a very good method. But you need to remember this equation. What is the general solution of a first order differential equation? This is for only for first order differential equation. Just mark this line, first order. Okay, so this is the general solution of first order differential equation. What is the solution? The value at infinity, the value at t equals to infinity plus bracket the value at t equals to 0 minus the value at t equals to infinity into e to the power minus t upon tau. That's it. Value at t equals to infinity plus value at t equals to 0 minus value at t equals to infinity into e to the power minus t upon tau. That's it. That's the final answer. Okay. So this is how we solve the first order differential equation, and this is the equation that you need to remember. Okay, just write it on paper, just highlight it. This is a very important equation for you in this complete chapter. Okay, so yeah. So in the next video we will, okay, before going to next video, one more thing, we will draw the graph. Okay, so yt I will write it down here. Yt is the value at infinity plus y of 0 minus y of infinity e to the power minus t upon tau. So now we will draw the graph of it. Okay. Look, if you take this equation, what is the value you will get at t equals to 0? At t equals to 0, you will get y of 0. That's very obvious. If you put t equals to 0 in this part, if you put t equals to 0 in this part, what will you get? This will be 1. Y of infinity will be cancelled with y of infinity. So you will simply get y of 0. And at t equals to infinity, what will you get? At t equals to infinity, this complete part will go down to 0, right? Because at t equals to infinity, this will be 0. So this complete part will go down to 0. So only y of infinity will be left. So you are rising from y of 0 to y of infinity, or you can fall down as well. Let's assume if your y of 0 is this, y of 0 is higher than y of infinity. So you will go from, this is your yt versus t. Now your y of 0 is higher. So you will go from y of 0 to y of infinity. Okay, y of infinity can be any value. It can be 0 as well. It can be any finite value as well. You will go from y of 0 to y of infinity. And if y of infinity is higher, so you will start from y of 0. This is your yt versus t. So you will start from y of 0 and eventually you will go to y of infinity, right? So that's how you are supposed to make the graph. And why the graph is like this? Because this is exponential. This is not linear, this is exponential. First, you need to know what is the general solution of a first order differential equation. This is the most important part of the video. Value at infinity plus value at 0 minus value of infinity e to the power minus t upon 2. This is the general solution of a first order differential equation. And this is how the graph goes. So that's it. That's it about the complete lecture. We have understood whatever we need to learn about first order differential equation or any order differential equation for network analysis. Okay. In the next video, we will start studying about capacitors. Okay. So we will see a very in-depth analysis and very different analysis. So I highly recommend to everyone to watch this video. Okay. Everyone should watch this video. You will understand many new concepts. Okay. So from next video onwards, we will start the real transient. Okay, this was the introduction. Now we will start the real transient analysis. Okay, thank you.